All right, so now we're looking at problems 9 to 14, and this is a soccer ball kicked with a horizontal velocity of 15 meters per second, and it hits the ground 3 seconds later. Okay, so we have a projectile that is a soccer ball. So let's see what we can find. So I'll draw a quick picture. So this guy must have been in the air when he kicked it, or this girl. So I'm going to draw a stick figure in the air kicking it. And there's the soccer ball. And its initial horizontal velocity was, in time zero, it was 15 meters per second, right? That's what we know. And after 3 seconds, there's our soccer ball. Takes 3 seconds to actually hit the ground. Okay? So, like always, you should be clear on how the horizontal motion and the vertical motion are different for a projectile. Vertically, we have basically an object speeding up from rest. That's in the y direction. And I can draw an acceleration graph to match that, because the acceleration is going to be that of the Earth's gravity field. We know t is 3, so therefore we know the change in velocity over those 3 seconds is going to be 30 meters per second. That tells us that our final velocity in the vertical direction, in the y direction, is going to be 30 meters per second. Okay. This is meters per second squared, and this is seconds. Just putting my units here. And this area here will tell us the amount that the soccer ball fell through the air. So this change in position in the y direction is going to be 1/2 of 30 times 3. So our change in position is going to be 45 meters. So that's how far the soccer ball falls in those 3 seconds. We can also figure out horizontally how far the soccer ball goes. That's going to be the area of our horizontal velocity time graph. So in 3 seconds, traveling at a speed of 15 meters per second, this area is going to be also 45 meters. And let me double check that. Yeah, 15 times 3. So it's kind of interesting. We get the same horizontal displacement as we get the height that the ball falls. So it turns out that the ball drops 45 meters in 3 seconds, and it actually moves 45 meters horizontally in those 3 seconds. So that seems kind of odd. So I'm going to put this guy on top of a building or something, and that way it'll at least kind of make sense. That would be a very tall building, actually, or a cliff. Anyway, that's about everything I could think of that I could solve here. For any problem that asks about the mass of the object, it's kind of an interesting question. Hopefully you realize that for all these problems, the mass of the object doesn't matter. The acceleration due to gravity is absolutely independent of the mass of the object. Anyway, thanks for watching, and I hope that helps you understand it. Have a good day.